Okay, so we talked about parallel and perpendicular slopes. So now we're going to look at how we can get the lines when we're looking at the slopes of different parallel and perpendicular lines. We learned that if I have a slope of, let's just say, 3, its parallel slope would be 3, because I need to rise and run at the same rate and never cross. However, the perpendicular line is the negative reciprocal. So it's positive here, therefore the perpendicular slope will be negative. This is 3 over 1, so the perpendicular slope will be 1 over 3. Okay? So we need to be able to recognize these similarities to determine whether lines are parallel or perpendicular. So you're going to be given an example such as this, and we want to know, are these parallel or perpendicular lines? Well, in order to determine that, we have to know what the slope is, right? So these are in standard form equations, right? This is ax plus by equals c. We don't know the slope, so we have two things that we can do, okay? Early on in our notes, we learned that when it's in standard form, the slope would equal negative a over b. Or, if I can't remember that, I can always change this into y equals mx plus b, get y by itself, and I'll know the m, okay? So in this case, it's pretty easy to determine that the a is 2, and the b, I should do capital letters here since I did capital letters there. The a is 2 and the b is 6. So if I'm going to use this formula, the slope would be negative 2 over 6, or negative 1/3 if I reduce it, right? So now looking at this one, my a is negative 3 and my b is right here, which would be 1. So the slope is going to be, I'm going to use this, negative, and then I plug in a, which is negative 3, over b, which is 1, which is 3 over 1, or 3. So the slope of the first, the slope, I gotta take these off, I can't see. This, oh my gosh. The slope of the first line was negative 1/3. The slope of the second line was 3. So we should see these are negative reciprocals, therefore they're perpendicular lines. Okay. Now, if this sort of equation of negative a over b is confusing for you, you could always just put this in slope-intercept form. I have 2x plus 6y equals negative 3. So I need to move my 2x over here. So that would give me 6y equals negative 2x minus 3. And then we divide by 6. And look, negative 2 over 6, negative 2 over 6, or a slope of negative 1/3. And then the same thing for the other one, negative 3x plus y equals negative 8. My head's probably getting in the way at some point, but we just add the 3x over here, and then we'll have y equals 3x minus 8. And again, the slope is 3, which is the same as what we found up here. So either way is fine. This is easy if you can remember the negative a over b. And it's really, we talked about this in class, it's negative a over b because I subtract ax over here and divide by b to get this into slope-intercept form. Really all we're doing to get that little equation is you're just putting standard form into slope-intercept form, right? So that would give me by equals negative ax plus c, and then divide by b. And then you can see that's y equals negative a over b x plus c over b, which doesn't matter. The slope is negative a over b. Anyway, short lesson there, okay? So because I've noticed these two, I can say these are perpendicular lines, okay? So then let's look at this one. This one I want to determine if it's parallel, perpendicular, or neither. Oops. So again, this is in standard form, ax plus by equals c. So again, I can do my m equals negative a over b. So I know a is here, which is 1. So that makes it a negative 1. And then b is 2. So I know the slope of that's negative a half. Now this one is in either slope-intercept or standard form. So this one might just be easier just to put it, you gotta put it into 1. So this one's just easier to divide by the 2 and put it into slope-intercept form. So that would give me y equals, remember there's a 1 here, 1 x over 2 plus 2. And then my slope here is a half. So here I have a slope of a negative 1/2. Here I have a slope of a half. They're not the same, therefore they're not perpendicular or parallel. And for perpendicular, it's a negative reciprocal. So although this is negative and that one's positive, they're not flipped. So it's neither. Okay? All right, let's look at a couple more things here that you'll have to do. The last thing that we'll be doing is where they'll tell us if it's perpendicular or parallel, and then we have to find that line. So if we look at this, it's telling us the line is parallel, okay? So I know that the slope here is 3 because it's in the m position. Oops, b. So I know my m is 3. And so it's telling me that this line is parallel to that. Therefore, this slope is 3. And I know it uses this point. It wants the equation of its parallel line. So we've done these before earlier in the year. We have y equals mx plus b. So I have an m, and I have an x, and I have a y. And so it's just plugging it in and solving. So for my y, I'm going to put in the 4. For my m, I'm going to put in the 3. For my x, I'm going to put in the 3. And then I'm trying to find the b. So this will give me 4 equals 9 plus b. Subtract your 9, and I know that b equals negative 5. So then for my final equation, y equals the slope, which is 3, and the y-intercept, which is minus 5. And this is the line that's parallel to this line. Same slopes, right? But this one has a y-intercept of negative 5. Okay, and we can do the same thing for perpendicular lines. We're going to practice this a little bit tomorrow. Again, I'm going to use the same line as above, so I know that my slope of that line is 3. Therefore, the perpendicular slope would be the negative, so it's going to be, that's positive, so this is going to be negative, and the reciprocal of 3 is 1/3, right? So now I know my slope of the perpendicular line is 1/3, and it goes through this point, 3, 4. So then I have the same approach. Y equals mx plus b. Plug in what you know. I know my y here is 4. I know my m here is negative 1/3. I know my x is 3, and then I want to find b. Okay? So I have 4 equals, and then negative 1/3 times 3. That just gives me negative 1. And so then I'll just add that over, and I'll know that b is 5. So then my equation of this perpendicular line is going to be y equals negative 1/3 x plus 5. That one is perpendicular to our original, which was y equals 3x. What was it? 3x plus 5. Okay, and we're going to work on this a little bit more in class. Have a good one.